Good evening, everybody. You're watching SDR Sharp right now, which I've got up on my monitor. And today I wanted to just look at the frequency response of my bandpass filter plus my preamp. Right now I've got everything powered off, and I'm just going to power it on here, and we'll take a look. I noticed the first time I powered it up, I saw some weird frequencies sweeping across my frequency of interest. It was weird to look at, but eventually it stabilizes as I would expect it to, centered on 7.2 megahertz. So here I'm going to power it up and let's take a look. Oh, okay. So I guess this time it just starts up nicely. So anyway, so what you're looking at here, I have a connection from my noise generator that I discussed in my previous video. I've got a length of coax connecting to the input of my bandpass filter. This is where my antenna would connect to. I'm filtering through my bandpass filter, and then the output from the bandpass filter goes into the preamp or the low noise amplifier here. And then I've got another piece of coax soldered at the end of my preamp, and then that signal is carried through to the SDR. The RTL, to be thorough here, it's the RTL-SDR version 3 that I'm using here. So previously I checked back on the video footage, it was minus 31, so about this level right here is what I had centered over my 40-meter band after I tuned up my filter properly, which means that I'm getting very little insertion loss on the bandpass filter. And then you can see, so if we just do a bit of addition or subtraction here, we've got minus 31 up to basically 0, maybe minus 1. Let's call it minus 1. Actually, maybe we can zoom in on this. Nope, wrong way. There we go. Yeah, let's call that minus 1. However, that's not over the entire range. Let's call it, so over the entire range, minus 20 to, I think the amateur band actually ends at 7.3. So yeah, minus 20. So we've got 10 dB of gain on the edges of our band, and 0, or sorry, let me think about this. So minus 20 at the edges, which would give us, from minus 31, it would give us 10 dB of gain on the edges of our band. And then at the center, we've got essentially 20 dB. So minus 31 to minus 1. Yeah. No. Wow. My math skills suck today. Essentially 30 dB, which is actually what the SPICE simulation showed. I'll pull that up here in a moment to take a look at. But this suggests that maybe I want to put a variable capacitor, like a trimmer cap, on my bandpass filter so that I can peak my filter, if I want to work in the lower part of the band here, because I'm losing a lot of gain right around here. All right, here we're looking at the SPICE model that I put together in LT SPICE for the preamplifier. I basically just shamelessly stole this from Charlie Morris. He's on YouTube, and honestly, I've taken a lot of tips from him, and I've basically been following his work fairly closely in terms of building my own transceiver. So here's our input signal, bypass cap to the transistor. We're just using a single 2N3904 for amplification. Filtering capacitors up here, 12-volt DC supply, a transformer. I'm actually using let me get this right this time, it's a FT37- I have the schematic somewhere. FT37-43, and I'm using it's 1, 2, 3, 4, 5, 6, 7, 8, 9 to 5 turns. So it's 9 turns on the primary and 5 turns on the secondary. And I've got a variable, what would you call that, a potentiometer here on the output to help match, impedance match the output. I use this spice directive here. It's a .NET I R6. R6 is this one, and then V1 is this here. And this actually generates S parameters for the circuit, which is the way I'm used to looking at results for circuits. So let's just run the simulation here. And add our S parameters. Here it is, S11, S12, S21, and S22. Let's get rid of the phase here to make things simple for ourselves. Don't plot the phase. So you can see here between at about 7 megahertz we're getting right around, it's actually in excess of 30 dB over our frequency of interest. Let's actually just zoom in on this, what's it, 7 to 7.3 I believe. Let's do something like that. So yeah, I mean, according to simulation, we should be getting 40 dB of gain. And then our impedance matching actually shows pretty lousy impedance matching. This isn't a proper RF circuit simulator, so I don't entirely trust these results. But in any case, looks like we're getting actually more gain in simulation than in practice. However, it's quite possible I set up the simulation incorrectly. I mean, even the S11 and S22 don't look correct. We should be getting 50 ohms since this resistor here, R3, should be determining our resistance on the input, our Z in. So we should be getting a better S11 than that. And on our output, we're looking in. This is supposed to be 200 ohms, a reactance of 200 ohms, and it's a 4 to 1 impedance, or a transformer. So we should be getting 50 ohms here. So anyway, with that, I'll close off here. Thanks for watching, and have a good evening. Night.